Okay, so a few little announcements here. Just a thing about the labs. They are in general due. We're basically making them due just so that you actually do them. Get it? Okay. Because, and it's not that we're trying to assess you as usual with homeworks and labs. We're just trying to encourage you to practice, because you really don't learn this subject matter by reading it. You actually have to do it. So we provided you some ways of doing that. Project Zero is out, and for those of you who would like to play around with the fully baked version, is available as there's a Piazza post about this. So the fully baked version is available on the instructional machines. You can run it and see what your project can look like when you get it working properly. And finally, HKN, Eta Kappa Nu, is an honor society in the ECS. They do a number of things, including run those little assessments at the end of each semester, and they'll be having drop-in tutoring available as announced here. So Monday through Friday in 345 Soda and 290 Corey. Now they don't exactly coordinate with us, so we also will have our own resources that should get announced in time. In particular, we're in the process of organizing some homework parties, which seem to be popular in other courses, so that people can get together and there can be lab assistants or TAs wandering around, and you can work, do a little collaborative work on homework, and perhaps do better and perhaps make a little more progress than when you're working alone and you get stuck on something. So we'll see how that works out. There will be further announcements on Piazza. All right, before we get into this, administrative questions or anything like that? Anything anyone would like to ask? Good, I guess. So today we're going to talk, this is conceptual sort of material, a conceptual material that people get confused about. So I'd sort of like to nail it down a bit. So in all programming languages, there are certain things that are universal. And one of them is that there are values. These are basically the data that you work with, or the identity of the data you work with. So we have, for example, numbers, we have characters, we have true-false values. This ground symbol is something that I occasionally use to mean to mean the null pointer. We'll get more on that later. And these other lines and things are generally things that I refer to as, I use to depict pointers. And then, so that's values. And these things are, you can think of them as Platonic ideals. That is to say, they exist out there in the universe. They cannot be changed. They are inviolable. 3 is forever 3, and A is forever A, and true is forever true, of course. So in order for anything to happen, and there is in fact a style of programming where the only thing that you deal with are values. You deal with, it's called functional programming. You've seen it or applicative programming. You've seen it in 61A, where all that you do is you create new values. And the whole program consists of creating a bunch of new values. But in fact, most programming also involves something else, namely containers that can contain values and whose value can change and whose contained values can change over time. So in Java, we have what I depict as simple containers, which I depict this way with little boxes with labels on them. And all of the simple containers in Java have, or at least, well, I don't know, Java 8 may have changed something, but all the simple containers in Java are labeled like this. They have some name, and they contain a value of one of these possible values that I show up on the top. And then you have another kind of container that I call a structured container. And this is a container that actually contains inside itself several simple containers. So you have, for example, arrays. We've been dealing with arrays on and off. An array is a container containing some number of simple containers, and each one of them has a label. In the case of arrays, the labels are integers. We can also define, as we'll see today, and as you have already seen in the reading, you can define new kinds of objects in which you have that contain simple containers, again, that have names that you give them, like H and T. Sometimes you'll see them written like this. There are various notations. That mean basically the same thing. You can even have structured containers that don't contain any containers. The empty object that contains nothing. It's not the same as null. It's just an object that doesn't happen to have anything in it. Sometimes called the unit value. Now, in Java, the structured containers don't have names. They don't have labels attached to them. Instead, what you do is you have a pointer, is that each one of them has a pointer pointing to it. And since pointers are one of these primitive values, you can then have containers that contain pointers that point to the object. So that you get a situation, something like this, where you have an array, for example, with that contains two simple containers, labeled 0 and 1, and the first one points to this other array, and the second one points to another array. So they each point to an object. But the array itself contains pointers. And this is where all the confusion arises. It arises because we tend to get confused between the pointer and the thing it points to. So you'll probably encounter this confusion at least once while you're programming, but we'll see. So again, a container can either have a name, which I depict with that letter with the name and colon, or it can have or it can be anonymous. And the rule in Java, at least up to now, has been that all the simple containers have names, all the structured containers are anonymous, and all the structured containers have pointers to them. So that's how it's done. And by the way, this is basically what you see in Python as well. There's nothing particularly new here. It's a very similar situation. Also in Scheme, this is an older slide, I guess, because I forgot to mention Python. But yes, it is very much the same in Python. So assignment now is very simple. Assignment means, in Java, this is not always true. This is not always true in other languages, but in Java, an assignment means that you copy the value. So if the value happens to be a pointer, it means that you copy the pointer. Right. So that's the idea, and we'll see how that works out. So let's just take an example. Here I can contain the other piece of the puzzle here is that you can define new kinds of objects. And as you saw in your reading, this is, and as you will see in lab, this is sort of the syntax for it. You define a class just as we have been doing. Everything's a class in Java. And you're allowed to put these variables in them, right? You'll notice that I don't use the word static anywhere. This is the distinction between a static function is just a ordinary function, such as you might define with def in Python outside of any class. And a static variable, which we haven't seen, but a static variable is simply a variable that exists. There's just one of them. and it just exists. It just happens to be defined in the class. But when I don't say that, then what I get is a definition that says every int list object, when you create an int list object, it will have two simple containers whose labels are head and tail. You need, in general, in order to create one of these things, it's useful to have a function that, when you create it, gives it some initial values. We call this in Java a constructor, and it has this kind of funky syntax. Now, in Python, this function was called underscore underscore init underscore underscore. You may remember those. In Java, for reasons that have to do with its heritage from C++, the constructor is looks sort of like a method, except it doesn't say what kind of value it returns. And it has the same name as the name of the class. So that's just a peculiarity. It's just something you have to get used to. That's the way it works. So inside public class int list, we have a way of building int lists. You give it a head and a tail, and what it will do is it will initialize, this particular constructor will initialize the head variable, the head instance variable here, to this value. It will initialize the tail instance variable to this value. I have written it out like this, as you'll see later with the projects and so forth. I have various conventions that allow me to be a little more concise. But what this means in this particular case is the int list object that you are initializing. So the head of the int list object that you are initializing gets set to this value. The tail of the int list object that you are initializing gets set to that value. So let's just look at a few examples here. We'll start out with, I'll define two int list things. And you'll notice that these are simple containers, L and Q, and initially they contain nothing. They contain the null pointer. The null pointer is a special pointer value that doesn't point at anything. It doesn't point at an empty thing. It isn't a pointer to anything. There's nothing it points at. It is, if you try to follow it, you will go off into the void and you will never be seen again. That's what it is. It's null. Now, I create then a new int list by saying new int list 3 null. And what that does is it returns this object over here, 3, and it creates a new int list object which contains a head and a tail container. And then the constructor that you saw in the last slide then initializes the head to 3 and it initializes the tail to null. I haven't put the head and tail are a bit too long to write, so I haven't actually written them on this particular for this particular slide. But for these little pairs of boxes, think of the first one as being labeled head, and the second one as being labeled tail. So I've done this. I've created this new int list. I have taken the value returned by new, which is a pointer. I have assigned it to L, so that L now contains a pointer to this object. And now in this second statement, I assign the value of L to Q. And the effect of this, and this is the sort of important point, is that Q now contains a copy of the pointer to this guy. So it doesn't contain a new object containing 3 and null. It contains the pointer that was L, that is in L, a copy of that pointer. And in fact, this is a uniform rule throughout Java. You're always copying pointers. You're always copying values of simple containers when you do assignments, or when you pass parameters. It's kind of nice that way. Other languages don't have this feature, but Java, up till now anyway, has had this feature. And I think there are various moves afoot to make exceptions, but it's a nice simple rule as it stands. So now the next thing I'm going to try to do is I'm going to try to add, this is obviously some kind of a linked list. You've seen those before. I think in 61A we called them R lists. I don't know if John has kept that terminology, but that's what I call them, for example, recursive lists. So I want to add another item to this list, the value 42, and this is how we can do it. We create a new object that contains 42 and null, and then I assign Q, the value of Q, the pointer that's in Q, I assign that to the tail object, to the tail container in the object pointed to by L. You can see how long this gets. I change the tail container in the object pointed to by L to point to the object that is pointed to by the value of Q. And so, of course, people take shortcuts and they say, I assign Q to L.tail or something like this, and that means, and people might misinterpret that as meaning that they somehow stick this object here into this little thing. They don't. You stick a pointer to it in there. All right, so now if I increment the head, if I increment the this 42 to 43, I can do that by looking at the tail of the thing pointed to by L, and then looking at the head of the thing pointed to by the tail of the thing pointed to by L, and then incrementing it. Right? So add 1 to it. So that's what this does. And you'll notice that the effect of this is that because Q is a pointer to the same object, it is an immediate consequence that Q.head is now going to be 43 as well. So this is sharing, as we call it. We have two variables that are sort of sharing the same value. So, and yet, this is just a consequence of applying these simple rules. When you do an assignment, you copy the value, period. When you, and then the fact that this dot notation means the tail container that is contained inside the thing pointed to by L. So the dot, again, means the thing whose name is on the right that is contained in the thing that's on the left, or the thing that is pointed to by the thing on the left. Okay, now I know that you will think that I'm hammering on this unnecessarily. I mean, you've seen pointers in Python and you've fiddled around with them, but people still get confused. So I'm going to hammer on this, dwell on this a little bit, if you'll forgive me, and give you another way of thinking of exactly the same thing that we're doing now, which is imagine that each of these anonymous objects has an address, like a street address. You have 7, you have 3, right? And you that means that, for example, in this case, as an alternative to this diagram, we could have this diagram where both last and result contain the street address of this object right here. And this object right here contains the street address of the next object. The advantage of this, or the potential advantage of this, I don't know, is that these street addresses work just like integers, and you don't make the mistake of thinking that just because you're assigning to an integer, you don't make the mistake of thinking that when you assign to an integer variable, you change something else as well. You don't make that mistake. So maybe, whereas people do make the mistake of thinking, oh, well, if I assign something to last, I might also change the thing that last is pointing to. So just in case you're inclined to make that error, perhaps this way of thinking of things helps. It's the analogy that I make is, okay, so assigning to a pointer looks just like assigning to an integer. And so this is what happens. It's as if in this particular case where I do last equals last.tail is, down here is something whose value is the label 3. And so the effect of this assignment, last equals last.tail, is that last now contains the address 3. Right? Now, internally, just in case you're curious, internally pointers actually are numbers. It's just that Java always hides this fact from you. There are some other languages that don't hide it from you quite as well. C is sort of notorious in this regard. You can, without too much trouble, take a pointer and say, let me think of this as an integer. And now let me add 32 to it, and now think of it back as a pointer, and do all kinds of terrible mischief. This is actually the basis, or has been the basis in the past, and apparently still now, for any number of attacks on programs where people go and make use of the fact that C is kind of sloppy, or C implementations tend to be kind of sloppy about this. Java, however, is not, and it won't make this confusion, even though, as you'll see, when you take CS61C, these pointers actually are nothing else in the actual machinery. They're actually nothing else but integers. But the moral here is that assigning to last does absolutely nothing to the thing that last is pointing to. It has no effect on it. So if you catch yourself saying, I'm going to assign to this variable, and that's going to cause this field over here to change, just realize that you aren't doing it. Think of it this way. In your address book, or your contacts list, or whatever, you might have the address of a former boyfriend or girlfriend. And erasing that address from your address book, alas, does not erase the former boyfriend or girlfriend. It's exactly the same way here. You can have pointers to things, and changing them isn't going to have any effect on the thing they point to. Just keep that straight, and you'll be fine, I like to think. Now, there are various ways. Before I go on to this, actually, I should mention that we actually have a beta test version of a visualization tool that you might use to sort of see how this thing is working. You've seen the format of this is quite familiar to you because you've seen it in 61A, I believe. So here is this is a link. We will put it up on the web page. I've already posted it on Piazza. This is a Java visualizer that works rather like the Python visualizer did. In fact, it's basically borrowed from the Python visualizer, except that they had to put in the machinery to make it work with Java, which is no small feat. Right? So I can, for example, in this particular case, I could define int list, but I'll be lazy about that. Let's say that we have an array. So I'll define an array A, which is a new array, containing 5 variables. And I can, for example, set A sub 1 to 15 or something. I don't know. 14. Okay, 14. Fine. And I can perhaps have another variable, another array variable, B, and I can make its value be A. And now we can visualize to see exactly what this does by pushing on this button. Oh, wait, no, I can't. I think this is because I'm not connected to the internet. Silly me. All right, let's fix that problem. Unfortunately, this means going through Air Bears, presumably, but we'll see. Yes. You are here, aren't you, Air Bears? Yes, thank you very much. Thank you very much. That's very nice of you. Let's see if we can do anything with this. Now, let's see if you can guess what my password is. Got it? Yeah, unfortunately, this does take a while. So, yes, it says it's still going. Still going. Still whirling around there. Don't you just love these little icons? Does Kelnet give you this much trouble? I mean, good grief. I guess you guys have to use it all the time. I'm spoiled with my stuff. Use Airbus 2. Let's see if maybe that will help. I have to what? All right, we won't use Airbus 2. We will, there we are. Authentication is complete. All right, let's see if we can make this work now. Processing my code. All right, here we go. So here we go. We're on this. Basically, we've started execution of this thing. We're now on the first line. We have not executed the first line yet. We are just on it. That's why it's shaded like that. And I can just click the forward thing here. And for some reason, it makes me click it again. I don't know. Now I've completed the first statement. So you see that A is pointing at an array over there that contains a bunch of things, including most of which are 0. And let's see what happens when I set A sub 1 to 14. Now we see that we've got A pointing at. I'll shove it over a little bit. Not that it matters too much. So now we see that we've changed the first element of A to 14. And now I can do another forward, and over this assignment here, where I assign to A to B, and what will happen? Yes. Oh, I'm sorry, that's the wrong forward. Wait a minute. Oh, there it is. I've got to wear my. And as you can see, we now have two pointers to the same. We now have two pointers to the same array. So you can play around with this. I think you're probably familiar with it. When you get more complicated objects, unfortunately, things tend to get kind of confused. You can already see that the two arrowheads tend to blend up there. But it's still, you might find it useful for understanding the elementary ideas of how these objects work. So I leave that to you. Then you can change the program however you want, like this, by typing edit code, and then run the thing again. So, for example, we could make this, I suppose, a two-dimensional array. That might be fun, or not. And then if I say A sub, and now I could try something like, well, let's see if you can guess. I'll set A sub 1 sub 2, oops, sorry. So let's see what happens when I set A sub 1 sub 2 to 14. And I'll get rid of this line for the moment because I don't want to redeclare it. Now, what do you suppose is going to happen when I do this? So let's just look at this here. So we do the visualization thing. Now, I should have mentioned, as you can see, what initially when we start the program, args, which is the argument to main, is pointing at an empty array. That's because when I ran this program, I didn't give it any arguments on the command line. So it's basically there. I just said run this routine, run this function, run class name here, and didn't say anything else. So that's why args is pointing at an empty array. Now, what do you suppose is going to be the result of executing this first line? Actually, here, just a moment. I think it might be more convenient if we changed the 5 here to a 3. I think that makes things a little nicer. I don't know why I chose 5, but there. Stupid. Okay, so here we are. Now, what is going to happen when I execute this first line? What do you suppose we're going to see when I execute that first line? Anyone care to guess? No, I'm sorry. Does anyone care to give me the answer? I wouldn't want you to guess. Really? Nobody? even in vague terms? Remember, you can always get points with the instructor by giving the easy part of the answer. Yes? A row of 3 containers. And what will those containers contain, do you suppose? Okay, let's see if that makes sense here. Sure enough. Okay. So now A sub 1 sub 2 means the second element means A sub 1. You evaluate that. And then you set its second element to whatever I have here, 14. What do you suppose this statement is going to do? Yes? You're guessing it's going to error. Why do you say anyone, why do you think it might error? Anyone who agrees that it might error, can you succinctly tell me why? Okay.
Because the first element's going to be a pointer to an array, but you haven't initialized the length of that array.
Well, what is A sub 1? What exactly is A sub 1?
It's null, but it should be a pointer to an array.
Yeah. So in other words, it's null, which means it's not pointing at anything. And so it's not even it's not an array. It's pointing at nothing, at the void. And when Java when you attempt to do that, let's see what happens. I hope it doesn't blow up. Program terminated. It says, and Java lang null pointer. You'll see this all over the place. Whenever you see Java lang null pointer exception means tut tut tut. You used a pointer value. You tried to follow a pointer value that was pointing nowhere because it was null. Okay, well, you can play around with this. Let's go back to the main program. Now, there's a little bit of terminology that we use in describing various programs, algorithms, and data structures. And this terminology has to do with the fact that we have pointers and things that they're pointing to. We call them destructive or non-destructive. So in this particular example, I propose to write a method, in this case a static method, that takes an int list and an integer and increments each value in that int list by n. Now, in this case, when I say I take an int list, I mean, of course, I take a pointer to a linked list of things, and I want to increment all of the elements. That's not quite. I mean, there is a clash of terminology here. Is an int list just this one object that I'm pointing to, or is it the whole line of things? Usually, it's clear by context. You've been dealing with recursive lists before, so I'm going to assume you know what this means. If you don't, speak up now. All right, so I'm going to return a new list that contains the values of each of the original list incremented by n. And I call this a non-destructive operation because I am not going to destroy any of the contents, the original contents of any of the objects that are floating around when I'm called. I'm just going to create new objects. So, for example, if I call Q equals incr list of L2, and L contains 3 and 43, as it says somewhere here. So I have a list L that contains 3 and 43, and I do an incr list on it, I will get back a new list that contains 5 and 45. That's my intention. We will then later see another version of this that I'm called deincr list. And the idea of deincr list is that it is a destructive operation. It destroys the original data. So in that case, what's going to happen is I pass in 343, and instead of giving me a new list, it's going to overwrite the original elements with new elements, and then the pointer that it returns will just be the pointer to the original list, because in both cases, I will end up with Q pointing to a list containing 5 and 45, but in the second case, it will I will have lost the original list, and hence we call this a destructive operation. But let's start with incrList and see how that's done. And here's my solution. It's a simple recursive solution to this. Now, question for you. Let's see if you can answer this. The answer is actually the same as it was in Python. So in this particular case, what this function does is that it goes through, it looks, in the case of an empty list, well, which as you've seen before with linked lists, an empty list is can be represented by the value null. So in the case of an empty list, the list that contains all the same elements incremented by 1 is just null. It's just the same list, the empty list. And otherwise, it's the list whose first element is the same as the original list, but incremented by n, and then the tail is the same as the original list tail, but with incrList applied to it. So it's a simple recursive. I'm using this simple recursive thing. Now the question is, I have this thing return its result. I return the resulting list. Why don't I just instead, could I just set p equal to that new value? And wouldn't that do it? I mean, then I could just say incrList of p by n, and p would now be a new list pointing to something that contained the values incremented by n. Why does that work? What's wrong with that? Why have I chosen to do return rather than assign to p? Anyone? Yes. Wouldn't I? Okay. I mean, what do you think would happen if I did exactly that? So I have, for example, back in this original program, I have L equal pointing to this list. I will call incrList. Forget about Q equals. I'll call incrList, and incrList will, as its last step, it will assign to L the updated value, the new list. So what is going to happen exactly? What picture should I draw? Yes? No? You're sure? Okay. Let's see. I see one hand I've seen before. Oh, okay. Uh-huh. Yeah, well, right. So what's happening is that, in fact, when I call incrList, what I'm passing as the first parameter is the value of L, not L. I'm passing the value of L. And so that means that inside incrList, P here is a brand new variable that just happens to have been initialized to the value that L had at the time of the call. So assigning to P doesn't do anything because assigning to a variable doesn't affect anything except that variable. So the fact that I copied P from some other variable, that information is lost, and assigning to P has no effect on L. We call this effect, namely that parameters are copies, are new variables, new containers that contain copies of the values. We call that call by value semantics. You will see if you go out there in the world and look at certain textbooks or blogs or so forth on Java, you will see that people say Java has call by reference. Those people are wrong. If you see that in a book, say, okay, fine, I have now calibrated this author. He doesn't know what he's talking about. I will go on to some other source. Right? So we are passing the values of things. Passing by reference is something entirely different, something that we don't actually have in Java at all, or in C for that matter. And If you are interested in it, well, you can ask me, but it's not here. Okay, so that's why I have to have IncrList return its result. And a second question about this, just to see how you're going here, what object gets created first in the result? What object is going to get created first by this? So I call IncrList P2, and as you can see from here, I'm going to create an object with a 5 in it, an object with a 45. So my question is, which of those two objects gets created first? Yes? Well, this is a program that goes step by step. So it gets an object gets created when you say new, or when the new actually gets executed. So we can't quite do everything. Everything doesn't quite happen at once. No. I mean, conceptually, from the point of view of the caller, it doesn't. They might as well both come into creation into existence simultaneously, but they don't actually. Any other takers? Yes.
I think the last object, the first list gets created first because list is created, and then the second box of the first thing is waiting for something else.
So you think that you're saying that you think that the 5 is created first. Okay. Anyone else have any contrary opinions? Let's see, any contrary opinions? Back there in the back there? No, your hand is not up anymore. Okay. Let's see. Yeah, go ahead. Yeah. Uh-huh. Right, so before I can create the first IncrList object, I have to first get the value of the tail and the second argument. And that means that I will be calling, that I'll be finishing this IncrList of P tail before I actually execute the new int list. Just as a point of information, is there something immediately after this class that explains why we have people leave early? Is there something? Oh, well, that could be it. I don't know. That might explain it. Okay, so now in this particular case, I'm not sure why I did this, but just to show you what's involved in doing the same thing iteratively, because maybe I'm just trying to rub it in that recursive programs have their problems, but they're often simpler than the original iterative than the iterative versions. So here's what you can do to do the same problem iteratively. A slightly different example. And I'll just explain this program, and you can go and meditate on it. So the first line is the same as before. If I get a P that's null, then I can, that means that the resulting list is going to be null, so that's easy. In this particular case, P is not null, so I come down to here, and I will create two variables, one of which points at the result that I'm going to create, and the other of which points at the last element of the list that I've constructed so far. So the loop now works like this. As long as we aren't at the end of the list, so the first item of the list, as you can see, is incremented. Then as long as we aren't at the end of the list, as long as the tail of P is not null, we advance to the next element. We set its value to to a new int list object like this, that's initialized by incrementing from the original list, and whose tail is initially null. And we point last at it so that we know where the last element of the list is. And then we will repeat this until we have creating 58 until we are done. And then finally, when we're at the end, we simply return the result. Okay. So that's it for today, and enjoy your labs.